So once again, decomposition is just breaking down. We have AB, which is our whole, being broken down into the parts, producing its parts of AB. That's decomposition. All right, and then notice the reaction at the bottom. Example reaction at the bottom. Okay, the next one. This is where it starts to get a little bit more detailed. Huh? We'll come back to it if we need to. Okay, we'll come back to it if we need to. So this one, single replacement. The next two are really they are what they sound like. Single replacement. And guys, just so you know, these are online as well. They're on Canvas. The exact same ones. Make sure you go in and check it out if you need to. Okay? So this is single replacement, and that's exactly what's going to happen. If you use your lettering system, let's go back. A plus BC. Right? That means we have a certain element added to two other elements that are combined together. And then what do we notice on the product side? So something's been booted, right? A has booted which one out? And now, B, and now B's by itself. One single thing has replaced one of the double things, and that's why we call it a single replacement. That's, once again, you're going to have to look at one of these equations and say, that is single replacement. All right? So here's a really good equation for this. We have magnesium reacts with hydrochloric acid. Remember, we've got to be able to formula right. To produce magnesium chloride and hydrogen gas. Now, a few things. Why in the world did I write this 2 for a subscript for chlorine? That's not by itself, number one. Where did that 2 come from on chlorine? It came from where? Magnesium. Guys, this is ionic, yes? Which means when I write this formula, I need to cross up charges. Magnesium has a +2, it crosses down to chlorine. Make sense? Why in the world did I write a 2 for hydrogen? That's Brinkelhoff. It's by itself. Does that make sense? Why am I telling you all that? Like, why is that important? Because these get difficult when I don't give you the products all the time. You have to, what we call, predict the products. Okay? Predict the product. And then when I say predict, it's not guessing. You need to know what the products are. How do I know what the products are going to be? Well, here's the next note that's not up here that you're for sure going to need to write down. And this is the new part from level into honors. Level kids don't really get taught this. Not anymore, at least. When I look at this, and I've noticed that this is a single replacement. That singleton looks to replace its own. What do I mean by own? Is that a metal or a non-metal? Magnesium is a metal, right? So if it looks to replace its own, it looks to replace a what? A metal. Now, I understand that this is hydrogen, but we know from ionic that hydrogen acts like a metal, right? So when this reaction happens, which one will magnesium try to boot out? Hydrogen or chlorine? Hydrogen, because that's the other metal in there, right? So when I go over here to predict my products, where I'm not really predicting at all, I know what it is from all these rules, it should be magnesium chloride, leaving hydrogen on its own. Y'all see what I'm saying there? Now, once again, the base thing for right now, if you want to just get the basics for today, that is identifying this as a single replacement, right? But by the end of the unit, you need to know that a metal will replace a metal and non-metal will try to replace a non-metal. Question? Am I?
No, that was the question. Making sure I got it down. So metal replaces metal.
Yes, non-metal replaces a non-metal in single replacement. Okay? Now, there's going to be one more step that we take next class, but we'll get there. I'm not going to overload you too much today.
Wait, so they only replace each other? So non-metal, non-metal, non-metal?
Yes. So, and there's going to be some equations where this is not a metal, it'll be a non-metal. right? And then when it goes to the ionic compound over here, it'll try to replace the non-metal. Most of your examples do involve metals, just so you know. But every once in a while I throw in a non-metal just to see if you're paying attention to it, okay? That becomes important when you look to when we go to predict the products. So a very good test question. You ready? A very good test question. In the directions it says, for the following, on your FRQ, hopefully you can visualize this, on your FRQ, for the following equations, do these three things. Number one, predict the products. That's what we just did here. After that, identify the equation. This is single replacement. Your third step is to balance it. Right? So a very good test question would be, I give you, let's do this, I give you none of that, and I tell you, I write in words, magnesium is added to hydrochloric acid. And that's it. That's all I tell you. You have to write down Mg plus HCl, so you have to be able to formulate acids. Then you have to be able to predict the products. Then from the reactants, be able to tell me what type of reaction it is. And then balance it all. Okay? Those get pretty intense sometimes. All right. The next type is what we call a double replacement. Two compounds react and the anion switch. So this one doesn't have the letter system on it. It has a good example at the bottom, but you should write the lettering system, the AB system. This is AB is added to CD. And in an ionic compound, which element is always listed first? The metal, right? So A and C are your metals, your cations. B and D are your anions. And it says the anion switch, right? So now I have AD plus CB. And that's what I see down here in this example equation at the bottom. You all see that at the bottom? The chlorine and the bromine have switched partners. Y'all see that? Why is this called a double replacement? Because two things are switching places.
No, I meant like was there a reference as a joke, like the other ones.
Now, these reactions get a little bit harder to balance sometimes because if I put a coefficient out here, what have I done? I've changed how many things? I've changed not only the A, but I've also changed the B. And so there's no singleton that I can leave for the very end. Once I put a coefficient out there, I've changed both of them. And that's where it gets a little bit difficult to you have to go back and recheck some things. These can get long, and the only hint I have for a true double replacement is to keep your polyatomic ions together. Try to balance them together. And we'll talk about that here in a second, but try to keep your polyatomic ions together and balance them together. Don't split them apart. If you split them apart, you'll still get it done. You can still do it. It just takes a little bit longer to do. All right? Now, these next two are really where you need to pay attention. Level did not learn this type. This is called neutralization. The first major detail that you need to know, and if your head's down sleeping, you're going to miss it, is that neutralization is technically a type of double replacement. That's a D. It's technically a type of double replacement. However, it's a specialized type of double replacement that involves an acid and a base. So if I give you an example of neutralization and you write down Dr as your answer, guess what happens? You get it wrong. It's just, I told you it's a detail. It's a small detail. But details can kill in this class, right? Some of you have found that out. Small details can really hurt you in this class. Okay? So, neutralization is an acid and a base. Now, you all have the skills to identify an acid. An acid is anything that has what in it at the beginning. So, this one has, acids always have hydrogen at the beginning of them, except for water. Yes? HCl, H2SO4, H2SO3, HCO3, H2CO3. Okay? All have hydrogen at the beginning. Now, I need to teach you about bases, and bases are anything that contains the hydroxide ion at the end. So now, instead of the beginning, I'm looking for the OH at the end. Examples: aluminum hydroxide, potassium hydroxide, sodium hydroxide, magnesium hydroxide, calcium hydroxide. What do they all have in common? Hydroxide. So they're a base. Y'all following that? So just like acids, they all start with H. Bases all end in OH, hydroxide. Okay? If these two things are added together, acid plus a base, they always, always, always produce salt water. And that's crazy. That should be a little bit crazy, because Friday for you, we're doing a lab in here where we use a very powerful hydrochloric acid that if it gets in your eyes, you might go blind, which is why we're going to be wearing goggles and aprons probably. Okay? How am I going to dispose of that when we're done? I can't dump it down the sink. I can't pour it in a trash can. How am I going to dispose of it the right way? I'm going to neutralize it. How am I going to neutralize it? By adding a base to it. Right? I pour a certain amount of base into it. It neutralizes it. And now instead of dealing with a powerful acid, now I just have salt water. That could be dumped down the sink. Or into a trash can and it dissolves. The water dissolves. It leaves over salt. Right? Pretty crazy sometimes. But you have to recognize that this is an acid and a base. Why is this beneficial to recognize this as neutralization? Two things. Because your products are always the same. A type of salt and water. A type of salt and water. Okay? Why do I mean a type of salt? Because last class, when we did the properties of ionic, what's the general term for all ionic compounds? Salts. Right? So is NaCl a salt? Yes. Is it the only type of salt? No, not at all. Not even close. Okay? It's just the most popular kind. It's the easiest one to work with. All right? So what I'm telling you is, let's say I don't give you the products again. You have to predict them. Yes? And you find that you're adding an acid and a base. What can you go over here right away and write? Water. And that's what you should do, because it's not HOH. We'll get to that in a second, why that's there. You should write down water. Because if you write down HOH as an answer on a test, I'm going to count it wrong. That's not the right formula for water. I'll tell you where HOH comes from here in a second. Does that make sense? So right away, you can write water as a product, because in neutralization, water is always produced. Where does that salt come from? Well, here is the only two things that are left over. Because H and OH are used to make water. Yes? So now, where did this NaCl come from? It's what's left over. Why is Na listed first? It's the metal. Metal's always listed first. So on a test, let's say you put ClNa because it's in that order right here. Guess what happens? You get it wrong, because the rule is metals are listed first. All right? A long time ago, we talked about that. Okay? Now, the trick is here, if you can recognize this as neutralization, here's how it's going to make your life easier when you balance this, because these can get kind of tough. The first trick I talked to you about was keeping your polyatomic ions together, right? And I had OH right here. Do I have an OH over here right now? Do I have a hydroxide over here right now? So I can't balance those together until I change water. Here is the strategy. I can turn water into HOH. Do I still have the same amount of atoms? Yes? So did I change anything chemically? I just manipulated the formula a little bit to make it easier. So now I can balance my hydroxides together. And now I can balance my hydrogens together. Okay? Here's why it's beneficial. If I go to this next slide, go ahead and write down this equation right here. You'll want to leave space for your coefficient. I did not, and I need to change that in my PowerPoint. But you'll need to balance this. So go ahead and write down that equation. So this is what you should be thinking when you look at this on your test or quiz. All right. So you're going to come up. This is let's say number 10 on your test or quiz, right? And it says, for the following equation, identify it, which means there's going to be a line out here for you to identify on, and then balance it, right? So how am I going to identify it? Well, I look at my reactants and I see an acid is added to a base. So what am I going to write on that identifying line?
Neutralization.
N. For neutralization, right? Then I go to balance it. Because I wrote that end on that line, now I know that the trick is to change that H2O into HOH. Okay? Here's where I've been confusing some people because of these H's and OH's and what do I balance with what, right? Why did I do that? That way I can now balance this hydroxide with that hydroxide. Notice how that hydroxide is really using one of those H's. So I'm going to balance these together, and I'm going to balance my hydrogen separate from that OH. Does that kind of make sense? So how many hydroxides do I have on my left side? One. There's only one there. How many do I have on my right side? One. They're balanced. Hydroxides are balanced. OH on the left, OH on the right. One of each, right? The next strategy is to balance polyatomic ions together and first. So how many sulfates do I have on the left? How many sulfates are SO4? Just one. How many do I have on the right? One. So we're good there. Hydrogens. How many on the left? Hydrogens on the left. Does everyone understand why there's only two hydrogens over here? Because this hydrogen is part of hydroxide. We're balancing that with that one. So we're not counting it as hydrogen by itself. Yes? That's what was confusing people in the last class. Okay? So we have two over there. How many do we have over here right now? Just one. So we need to change that to a 2. When I do that, now how many hydroxides do I have?
2.
Which means I need to change this to a... But the good thing is when I change that to a 2, now look at your potassiums. That's balanced. Now, guys, listen, I'm doing this in my head. Of course, most of you probably would need to do this on paper, balancing on both sides, right? Using your atom counts and all that kind of stuff. It would take you a little bit longer than I would, but that's the gist of it. The big part is to make sure you balance your hydrogens together and your hydroxides separately from your hydrogens. Okay? So the one at the bottom, this is more test-like. Why is it more test-like? Because what do I not give you? No products. So your train of thought should be, I need to identify what type of reaction it is before I get to my product, so I can get to my products. I have an acid plus a base, so what product do I know of right away? Water. Well, I have water, and I should be making some type of salt right here. Well, this water took up the hydrogens and took up the hydroxide. What's left over? Sulfate and lithium. So which one? They come together because this is a type of double replacement, right? So what is my formula for when I combine lithium and sulfate?
Lithium sulfate.
What's the formula, not the name? And that would be incorrect. Why is it Li2SO4? Because sulfate has a what? -2 charge. See how you forget these rules? You can't do that. Yes. The H2O? Because we just straight out memorized that neutralization produces salt water. You see what I'm saying?
Oh, okay.
It's not, I could, technically, it comes from the HOH. But then you're thinking, well, hydrogen has a +1, OH has a -1. Where'd the 2 come from? You see what I'm saying? That's why you're just going to straight out remember neutralization. And it's going to be even more for the next one that we do. Okay? That's why it's important that you recognize this as neutralization. Right? So now that we have the right formulas, we've just predicted the products. Like that's what predicting products is. You come up with the right products from the rules from what type of reaction it is. Okay? Then I know that's neutralization, so I'm going to cancel out the H2O and put HOH. Now I'm getting kind of messy up here, so I'm going to do some erasing. Say it again.
When do you convert it to which? Like the HOH and H2O?
So you start off, because this is neutralization, right? You know that it gets salt water. Yes? So the correct salt is Li2SO4. Does that make sense? In water. Does that make sense? Right? So now you need to balance it. Guys, this turning it into HOH is just a strategy. You don't have to do it. It's just going to take you longer to do. And you might have to go back and reduce coefficients. So that's why I'm teaching this to you. You only do this with neutralization. That's why it's so important that you recognize it before you get started with anything. So I'm going to cross that out for right now and say HOH is the same thing. Does that make sense? Why am I doing the HOH? What's the purpose of that? To balance the hydroxides on both sides. Because remember how bouncing polyatomics together makes things easier? So now how many hydroxides do I have on the left? How many hydroxides do I have here? How many do I have on the right? 1 and 1. I'm good. Then sulfates. How many sulfates do I have on both sides? 1 and 1. Yes? I'm good there. Go to the hydrogens. I have 1 hydrogen here. How many do I have here?
2.
So I got to make a change. So I put a 2 right there. Because I did that, now how many hydroxides do I have?
2, 2, 2.
Which means I have to go back over here in front of lithium and put a 2. That gives me 2 hydroxides. Does that make sense? And the good thing is, if I wrote my equation the right way, I see that there are 2 lithiums. How many lithiums do I have on the right side? But the majority of you, if I didn't correct you, you would still be trying to balance this because you didn't have that 2 there. You see what I'm saying? And you would never have an ending spot if you didn't write the formula the right way. You'd keep going and going, or just say, screw it, blank, go to the next question. Right? It all really comes back to formula writing. That's neutralization. Acid plus a base. It is a type of double replacement, but if you write double replacement, it's going to be wrong. The next thing that you need to detail that you need to know, and if you're paying attention, you're going to get, and if you're sleeping, it's going to go right over your head, is I told you about the HOH strategy, right? Guess what happens if you leave HOH in your final answer?
It's wrong.
What's the formula for water? So if you don't write H2O for water, you're going to get it wrong. Now, you all get lucky because all my kids did this last year when I taught them this, because I didn't think I had to tell them to turn it back into H2O. But I did because they all got it wrong. All right, so I get to tell you now, if you leave it at HOH, it's going to be counted wrong. It's just a strategy to help you balance faster. All right, turn it back into the right one.
So when you turn it back,
Keep the coefficient. Once again, it's just a strategy to help you balance faster. All right. All right, the next one. Come on. Is combustion. The last one is combustion. Here's where you really have to identify to make your products make sense. Are you ready? So, this is called combustion, more specifically the combustion of a hydrocarbon. Okay? What does combustion mean? Fire, blowing up, exploding. Yes? All of those would be acceptable. Which means the base of all of those are some type of fire. Right? On Earth, I don't know about any other planet, but on Earth, fire has to have three things a part of it for it to happen. Oxygen is one of them. What else?
Heat.
Some type of ignition or heat. And the third one is carbon dioxide puts it out. That's what's in your fire extinguishers. What's the third thing every single fire has to have? Something to burn, fuel. Could be that. Could be, this is what we call hydrocarbons. A C and then an H is a type of hydrocarbon. Most likely, it's a type of something with an ane. What do I mean? Propane, octane, methane, hexane. Okay? Those are all combustible, highly combustible gases, like in your propane tank. That's why they're held outside of stores. Highly, highly combustible, which means they blow up. Okay? If I add an O to this, CH and O, biology people, that you remember last year, you have a carbohydrate or lipid, depending on what the ratio is. Okay? Those are just types of hydrocarbons. Okay? Now, why is this so important that you recognize a hydrocarbon being added to oxygen? Because this is what causes the combustion. With the right amount of heat or ignition, it's going to blow up or set on fire. Right? What you need to know and what you straight need to memorize, kind of like going back to Ellie's question last time, like how do we know what's what? Because you just got to memorize it, right? Is that it always produces carbon dioxide and water. Why do you have to straight out memorize what the reactant or the products are of combustion? Because this starts off, what does the reactants look like? What reaction that we've already learned? Look at the reactants. Which one of them appears that we're going to be working with? The single replacement, right? Here's your BC, there's your A. It appears like it's single replacement. But then look at your products. It ends like which one? Double replacement. Is that possible? Well, yeah, in combustion it is. So if you try to do the whole switching the anions or switching the metal and the non-metal and the metal and metal, that's not going to work. You see what I'm saying? You have to notice that this is a hydrocarbon added to oxygen. We always produce carbon dioxide and water. So right now,
those elements?
what's that?
Is it always going to be those elements?
Yep.
Or is it going to be different?
So on the left side, really this is the only one that's going to change. The only thing that's going to change about it is the subscripts and the coefficient when we balance it. Because it's going to have a different type of fuel, right? Oxygen's always going to be there, carbon dioxide and water. The only thing that's going to change about these Ours is your coefficient. That's why it's so important that you study these and you know, okay, combustion always carbon dioxide and water, and oxygen is always going to be right there. Okay? Not difficult if you look through it a couple of times and practice it at home. Okay? So right now your body is going through combustion. Why is that? Because we're breathing. What are we exhaling, Sam? And water. When you go to breathe on the glass to write your name in it on the bus or draw all those inappropriate pictures that you do on the fog of the glass, that's water vapor that you're writing in, right? So right now, every time you exhale, you are combusting glucose in your cells, which is giving off CO2 and water. Okay? Now, here's why it's so incredibly important to recognize this equation. Because there's a very specific way that we can balance these that make it so much easier than what y'all were doing last semester. These are the ones that get really big coefficients, like 25 and 13 and 17 and 16. You guys remember those questions? If you actually, some of you just said, I'm done, I'm not even going to try it, and went forward. Some of you did it for like 45 minutes and still didn't get it because you're going back and forth so much. If you memorize these steps, there's 3 steps, and you're going to be done and get it right every single time. But once again, it takes practice and staying awake in class to get it. Okay? You have to practice this to remember the steps. Here are the steps. You ready? So, your first step, recognize that it's combustion. That's essential. Okay? Your next one is balance your carbons. So here we go. The first one. Balance your carbons. How am I going to make 3 carbons on the right side? The coefficient in front of carbon dioxide is what?
3.
Put a 3 there. Pretty simple there. Your next step is balance your hydrogens. Well, I have how many here?
8.
I have 8 here. I have 2 here. How am I going to balance?
4.
Put a 4 there. Now, in step B, this is the one that you have to practice with. It says, if water has an odd coefficient, double it, make it even. To make it even, then rebalance your hydrocarbons. That's kind of involved. But is that number odd or even? Even. So do I need to do any of that mess? At least not on this one. So I'm done with that one. I can move forward. Then balance your oxygens. So here was the biggest question last semester was, well, I have oxygen there, I have oxygen there. Do I need to add those together or do I keep them separate? At the end of the day, oxygens on the right have to equal oxygens on the left. Yes? So how many total oxygens do I have on the right?
10.
3 times 2 is 6. 4 times 1 is 4. I have 10 total oxygens on the right. How do I balance 10 on the right with the left? Put a 5 there. Why in the world does it make sense to balance your oxygens last? I kind of already mentioned it once today. It's by itself. If I can figure out that is balanced with that, and that's balanced, remember the strategy was to balance your singletons last?
What if oxygen's not the last one?
If you do these steps, it will be. Because it's the last step. It's C. You see what I'm saying? That's why it's the last one. Because once I've balanced all of that, I can make this oxygen virtually whatever I need it to be to make it work. So we just added a 5 and we're done. That's the strategy behind leaving it last. Now listen, I didn't tell you all of this last semester, and many of you got the combustion reactions correct. So is it possible to do these without remembering this? But it will also take you a lot longer.
Does it have to be like hydrogen and hydrogen?
That's my suggestion, yes. Okay? So, all of these shortcuts, you don't have to practice, you don't have to know to get things right. It just saves you a lot of time and a lot of headache. Chances are, you have to go? Yeah. chances are, if you don't do this in combustion, you're going to have to go back through and reduce coefficients to the by the least common factor or the greatest common factor. Okay? Doing it this way, you don't have to do that. All right? The next one, more test-like. You have this hydrocarbon reacts with oxygen. What do you have to do first? Predict the products. And when I say predict, once again, it's not guessing products. You are figuring out what the products are. Now, once again, what's the funny thing about combustion products? They're always CO2 and water. Notice how we didn't say, okay, this switches with this switches with that. Look at your metals and metals, and it's just CO2 and water. Now, you go back through these steps.
Will you have like all the other like replacement type of things? Are they ever gonna have like both CO2 and H2O on the product side?
No,
So,
not without being combusted first.
so it'll always be.
So you're trying to find quick ways to identify these, right? That's perfect. That's what you need to do. But be careful because I won't always give you the products, right? So really look at the reactants.
So it'll just always have CHO. Will the others have CHO?
So it's going to be CH plus oxygen, or it could be CHO plus oxygen, right? So here we go. Balance your carbons. I have 2, I have 1. How many of you started with like that? Put a 2 there, right? Balance your hydrogens. I have 2 there. Sorry, I have 6 on the left. How am I going to get 6 on the right? Put a 3 there. Then a little red flag should be going up in my head because it's odd. What do I do if it's odd? I double that number to make it
6.
That's what I mean by that little note. Not difficult, right? But it's, unless you do it with me, it's kind of hard to say, like, what do you mean by that? That's what I mean by that. Double it to make it even. Any odd number doubled will always be even. Right? So then, if I doubled it, now I got to go back and rebalance my hydrocarbon. Because how many hydrogens do I have now on the right side? 12. I only have 6 over here, so I got to put a 2 there. But by putting a 2 there, I've also doubled my carbons, so just a quick fix of 4. What's that? So we double this to make it even.
Is that like a rule?
Yes. Yes, we double that to make it even. Then we got to go back and rebalance our hydrocarbons. Right? Now here's really why. Here's the answer to the why do we have to double it to make it even? Because O2. Yeah, right? If it's an even number, I can put any number here, multiply it by 2 to get an even number. Does that make sense?
Yeah.
All right? That's the purpose behind it. All right? So now I need to add up all my oxygens. How many total do I have? I have 14 on the right, which means 7 on the left. That's what I mean by we can make that any number we want to make it work as long as we've done the right side together. Or the right way. So your coefficient ratio is 2 to 7 to 4. Sorry, to 6. Dang it. To 4. I was right the first time. 4 to 6. That better? Why am I doing that? Is this a good coefficient ratio? Why is it good? Can't be reduced, can't be simplified. You need to check that when you do combustion. All right? Any questions there?
Are we allowed to go back to the other replacement that we
Yeah, we'll get there in a second. Well, let's do. So now this is the basis for today, right? If you learned something today, you should be able to identify all of these reactions as one of the 6. All right, ready? I'm going to call on volunteers, not volunteers. If I don't get any volunteers, I'm going to call on random people to come up here and write down the first letter of each type of reaction. Do I have anybody that wants to volunteer just in case I call your number out and you get to pick whichever one you want? You don't have to do them in order. That's all. 1, 2, 3, 4, 5. Come on up and pick one, whichever one you want to do. On the right side, because those lines don't match up.
I'll take the 6th one.
I think there's only 5 up here right now.
I'm counting 6.
Oh, yeah. If you don't want to do, you want to get a different one? Hmm?
Sorry, you're good.
You good?
Yeah. I just want to shoot.
Oh, you're good. Because we don't have an acid up there or a base.
How do you know if it's an acid or not?
We'll talk about that in a second. There's an example coming up.
This one's single substitution, right? Right, I think that's what it is. It's single because we have 1 here.
Okay, write it down. Put an SR if you think it's single replacement. There you go. We got one left. Do I need to be mean and pick a random number? Okay. There you go. So right now we got decomp, synthesis. We got double replacement. That's a terrible D. We got single replacement and combustion.
Fingers crossed.
Okay. Thank you.
Yeah.
All right. Any issues with what you see up here?
Nope.
Okay, how about this? First one, do we have a product being broken down into its parts?
Yes.
Decomposition is correct. Next one, do we have parts, for synthesis, do we have parts making a whole?
Yes.
Yes, we do. Cell phone should not be out right now. If you got a cell phone on your desk or you're on it, get it put away. The next one, double replacement.
That's single replacement, isn't it? Just the only one after. So that's
We have a single here and a single here.
yeah.
So what should that one be? That one should be single replacement. Y'all see that? That's the easier of the two single replacements. The next one is the harder of the two because a lot of us get confused and causes anxiety with the pi-atomic ion there. Remember how I said pi-atomic ions stay together? You can think of them as one thing. So here's your A, B, C. Yes? Your pi-atomic ion's one thing, and then we still have a single there and a single thing that got kicked out here. So this is single replacement. The next one is double replacement because A, B, C, D, right? And then your B and D switch places. And the bottom, combustion because of your hydrocarbon added to oxygen, and then obviously your carbon dioxide and water being produced. Okay? Now, the extra things that we've learned today are all of the hints, are all the strategies to make balancing these things faster. The base of what you need to know today is this right here, being able to identify. Okay? So here we go. Identify these. Any volunteers for this first one? Here. That is, pick a number. 14. Oh, pick another number.
16.
There you go, Dre, right? Is that you? There you go, 16. What do we have here? By all means, look at your notes as much as you need to. Guys, this is really part of your quiz, so you all should be trying to do this, not just staring up here. You should be able to do this in your head. We have a single thing here. Single replacement, because we have a single thing here, trying to jump into that double. Okay, so that's single replacement. Pick a number, Brandon. 22. Someone. What is it? That is decomposition because we have a product being broken down to its part. Pick a number. Or a person.
Double replacement? No.
Oops. Oh, I just showed you. Did you see it?
Yeah.
What is it?
Combustion.
It is. Why is it? How about that? Why is it combustion?
Carbon dioxide and water.
Are produced, right? And then we have a hydrocarbon being added to oxygen. Oxygen, right? That is combustion. Yeah, lucky. Let you off the hook there. Pick a number.
17.
17. There you go. Double replacement. Now, that's halfway right, correct? I told you all that this would be like the biggest mistake in identifying, probably, because this is a type of double replacement. So you're not completely wrong. However, it's a certain type because those of you that aren't quite sure what acids are, and I just taught you what a base was, so we should not be on cell phones right now because this is new for us, right? Anything that starts with an H is an acid besides water. Yes? Anything that ends in an OH is a what? Base. When we add an acid with a base, we always get salt water. Hmm? Hmm?
Is that in like the other options stuff?
Yeah, so we did a single replacement with a metal and an acid. Look at your single replacement notes if you wrote it down. Magnesium plus hydrochloric acid. Right? So, that is neutralization. All right? Now, for your reference, and I already showed you this once. Hopefully it's still up. Okay? Here's what your Chem Quiz dashboard looks like. It says predicting homework practice. This is what we're doing tonight. Yes? There are 10 questions, but, hey guys, I'm not grading it. I'm not even looking at it if you did it. But I'll know for darn sure if you did do it when you take your quiz on Wednesday. Okay? If you take these 10 and you get 6 out of 10 right or 4 out of 10 right or less, you should probably redo it. I set the settings to where you can redo this as many times as you want. If you get 10 out of 10, you're done. Oh, I'll bring it back up in a second. What about it? That's the minute. We don't redo quizzes. Did you look at your answers? Most likely you didn't write your formulas right. You gotta be in class. All quiz. Now, you can come in for an Eagle's Nest or after school.
I can't do Eagles Nest or a...
We're gonna have to take some classes. Okay. Yes.
Poi mi ha mandato l'email.
Cioè, mi ha fatto vedere. Ma mi ha detto di far finta di non vederla perché così vuole fare una sorpresa.
You can today, but no, not every day.
Oh, can I have them now?
And wait another minute and you can go.
Cavolo, io devo fare la pipì in una maniera indecente.
Sono in bagno un'ora fa.
Eh?
Sono in bagno.
Here's that
Ah,
code.
ma ho
if
anche
you need it.
bevuto!
Eppure io.
Vabbè, però io ho la vescica piccola. Al cipro.
Here's the code if you need it. You need to get signed up to make sure you're
Quando
getting the
cipro la
homework
mia
done.
vescica fa ui. Sì.
Ma io sono sicuramente con anche tu tanti di notte, anche Martina.
Siamo sincronizzati?
Io no, però io ero settimana scorsa, siamo quasi sempre.
Ah,
Martina,
guarda,
sì, sì, Martina,
io e la
perché
mia
hanno
amica,
preso-
io e una mia amica, io e Angelica, no? Eravamo, se lo avevo io, entro 2 o 3 giorni lo aveva anche lei. E poi ci sono 3 tipi all'atletica, sorry. Che una lo ha, dopo una settimana dopo e una settimana dopo ancora, no?